Hello dear students, in today's video lecture we will study central differences, and using these central differences we will create a central difference table, and later we will study the Bessel's interpolation formula. The central difference operator, which is denoted by small d, is defined by the relations y1 minus y0 is equal to delta y of 1 plus 0 by 2 is equal to delta y of half. Similarly, y2 minus y1 is equal to delta y of 2 plus 1 by 2 is equal to delta y of 3 by 2. Similarly, if we proceed this way, yn minus y of n minus 1 is equal to delta y of n plus n minus 1 whole divided by 2. So, we get yn minus y of n minus 1 is equal to delta y of 2n minus 1 whole divided by 2. On calculation, we get yn minus y of n minus 1 is equal to delta y of n minus half. Similarly, for high order central differences, we can define as delta y of 3 by 2 minus delta y of half is equal to delta square y of 3 by 2 plus 1 by 2 whole divided by 2. On solving this, we get delta square of y1. Similarly, for delta y of 5 by 2 minus delta y of 3 by 2, we get delta square of y2. Therefore, the central difference table can be written as, for the values of x, we have x0, x1, x2, x3, x4 and x5, and for y is equal to f of x, we pass the values of x through each of y, and we get y0 for f of x0, similarly y1 for f of x1, etc., y2, y3, y4 and y5. We get the central differences y1 minus y0 is equal to delta y of half. Similarly, y2 minus y1 is equal to delta y of 3 by 2. y3 minus y2 is equal to delta y of 5 by 2. y4 minus y3 is equal to delta y of 7 by 2, and y5 minus y4 is equal to delta y of 9 by 2. For the second central difference, we have delta y of 3 by 2 minus delta y of half is equal to delta square y1. For delta y of 5 by 2 minus delta y of 3 by 2, we have delta square of y2. For delta square of 7 by 2 minus delta of 7 by 2 minus delta y of 5 by 2, we have delta square of y3. And similarly, del y of 9 by 2 minus del y of 7 by 2 is equal to delta square of y4. For the third central difference, we have delta square y2 minus delta square y1 is equal to del q y of 3 by 2. For delta square of y3 minus delta square of y2, we have del q y of 5 by 2. And for delta square of y4 minus delta square of y3, we get del q of y7 by 2. Similarly, for fourth central difference table, we have delta q of y5 by 2 minus delta q of y3 by 2 is equal to delta 4y by 2. And for delta q of y7 by 2 minus delta q of y5 by 2, we have delta 4 of y3. And for the last or fifth central difference, we have delta 4 of y3 minus delta 4 of y2 is equal to delta 5 of y5 by 2. So, this is our central difference table, and using this central difference table, later lecture we will study Bessel's interpolation formula. Thank you.